The inverse of an exponential is called a logarithm, but to shorten it, they're just referred to as logs. There are quite a few laws for logs which you need to know. You don't need to be able to quote them, but you do need to be able to use them. So the first is the equivalence rule. So log base a, which is what we call that little a, so log base an equals x is equivalent to a to the power of x equals n. So, for example, let's say if I have 3 squared equals 9, the equivalent would be log base 3 9 equals 2. And similarly, let's say if I have log 3 base 3 81 equals 4, that's the same as 3 to the power 4 equals 81. They're equivalent, they're like interchangeable. You want to get comfortable with that as quickly as you can, because they come up and making use of that rule comes up quite a lot. And then you have laws of logs. Just how you have index laws, like laws of indices, so if you multiply two indices, you actually add them together. That same kind of thing applies here. So I would suggest writing down these laws. Either write them on flashcards, or you can just write them on a piece of paper and try and commit it to memory, completely up to you. But I would definitely suggest writing it down. Now, what I'm going to do is go through a question which makes use of using log laws and solving equations with them. So the first one, log base 10 4 plus 2 log base 10x equals 2. Out of all the laws that we have, which can we use? So we can use this one, the power one, and this one, the multiplication one. Okay, so let's start off by using the power law. Let's change this log. So log 10 4 plus log 10x squared equals 2. That's me making use of the power law. Now I can use the multiplication law. So log base 10 4x squared equals 2. And now we can use the equivalent rule. So 4x squared equals 10 squared. And now it's just a matter of simplifying. So x squared equals 25. So x equals 5. Cool. Remember, logs are always positive. So log 10x is always positive. So where technically I would get plus minus 5 after square rooting, I would only take the positive answer. Cool. Let's have a look at a different type of question. Something like this. Write in terms of log ax, log ay, and log az. So we want to make it larger. We want to, spread things out. Kind of going in reverse. So here I am timesing x squared, y, and z cubed together. If I use the multiplication rule, I get this. And then using the power rule, you get this. There you go. That would be your answer. That's a different type of question that you could potentially get. Oftentimes, though, you're going to get solving type questions. So, that being said, I've put up question 4 and question 5. I want you to give those a go for me, please. For A, we're going to make use of the multiplication rule. So log 2, 3x equals 2. And now we do the equivalence. 3x equals 2 squared. So 3x equals 4. X equals 4 over 3. Okay, B. We use the subtraction rule or the division rule. So log base 6, 12 over x equals 3. We do the equivalence. 6 to the power of 3. So that means 12 over 6 to the power of 3 equals x. Move this there, move that to the other side. Okay, so that means you end up with 1 over 18 after simplifying 12 over 6 cubed. Part C. You want to put all the logs on one side. 2 log 5x minus log 5 6 equals 1. Use the power rule. Like that. And now division. X squared over 6 equals 1. And now the equivalence. X squared over 6 equals 5 to the power of 1. X squared equals 5 times 6. X squared equals 30. X equals root 30. Okay, last one was D. So first step would be to put all the logs on one side. So you get 2 log 9 x plus 1 minus 2 log 9 2x minus 3 equals 1. Now use the power rule. X plus 1 squared minus log 9 2x minus 3 squared equals 1. Now we do the division. Whoops. All of that is going to be to the log base 9. That equals 1. We now do the equivalence. X plus 1 all squared over 2x minus 3 all squared equals 9 to the power of 1. Now, let's say if I rewrite this as all of this squared, and then I square root 9, I get 3. Take the 2x minus 3 to the other side, and you get 6x minus 9. Then you end up with 10 equals 5x, so x equals 2. Okay, that's question 4 done. Question 5. Given that log base 3 x plus 1 equals 1 plus 2 log base 3 x minus 1, show that 3x squared minus 7x plus 2. Okay, so let's move all the logs to one side. And let me do the question here. So log base 3 x plus 1 minus 2 log base 3 x minus 1 equals 1. Now we use the power rule like this, and now we can do division. Now we can do the equivalence. And now it's just a matter of solving. So x plus 1 equals 3 times x minus 1 squared. So x plus 1 equals 3 times x squared minus 2x plus 1. Expand. And now shift everything to one side. There we go. And that's what they wanted us to show. Hence or otherwise, solve. Okay, so from here, now it's just a matter of factorizing. So when we factorize, we get 3x minus 1, x minus 2 equals 0. So x equals a third, x equals 2. Yep. If x equals a third, one of our logs contains an x minus 1. Okay, if x is a third, x minus 1 would give us a negative answer, which doesn't work because you can't have a negative log. So your only solution is x equals 2. But there you go. Those are the log rules, and that's how you use them when solving.